Whew. So guten Abend. Hello world. So we're here, and oh man, suddenly I'm feeling tired again. Oh, I'm kind of tired, but I wanted to stream, so just wanted to put some work on this problem. Oh boy. So good evening. What we're going to work on today is the same problem I've been trying to sort out the past few days. A lot of hours into this, but we're learning quite a bit. Actually, a lot of different things we're learning. So, lexicographical order, so I'll read the problem again, is often known as alphabetical order when dealing with strings. A string is greater than another string if it comes later in a lexicographically sorted list. Given a word, create a new word by swapping some or all of its characters. This new word must meet two criteria. It must be greater than the original word. It must be the smallest word that meets the first condition. For example, given the word ABCD, the next largest word is ABDC. Complete the function bigger is greater below to create and return the new string, meeting the criteria. If it is not possible, return no answer. So I'll explain the algorithm sort of quickly. We've already solved it. So as an example, right, ABCD, you would swap C and D, and you get this new larger word that's also, it's the smallest such larger word. Now, the thing to talk about here is what's it saying? Sorry, I'm sleepy. We did solve this, and I'll explain the algorithm. I'll go through it here. And we found an optimization as well. So what you do is you find a character, search from left to right, and you find a character such that it has a greater character to the right of it, right? Lexicographically larger character to the right of it. And you're going to find the largest, the furthest to the right such character. So there's at least one character to the right of it that's larger. And you can go left to right to find this. As it turns out, this is a very efficient way to find this, is you just look at all of the indices such that the index to the right of it represents a character that's larger. So index x, the character at that index is smaller than the character directly next to it at index x plus 1. And then if you take the largest of all those indices, then you will find the index that we're interested in necessarily. And that's what this does, this line. And the proof for that, it's a strong induction proof, because you don't see what you could do is actually use a stack-based algorithm to perform this search. And what you would do is you would pop the stack for all of the, you basically would say, okay, at each step we're going to push onto the stack the value that we're looking at. But if the value we're looking at is larger than what's on top of the stack, then the thing that's on top of the stack is one of these elements that we're interested in, that this index that has something to the right of it that's larger. And so now what you want to do is compare that index to the current rightmost index, and then you pop the stack all the way down until all the elements that you've pushed onto the stack are larger than the next one, or smaller than the next one, rather. What's interesting about this, though, so that gives you the solution you're looking for, the index you're looking for. What's interesting about this is that you don't actually need to pop anything off of the stack, because because we're looking for the largest value from left to right, popping off the stack, you'll only end up looking at indices that are smaller than the one you've just looked at. So you never actually need to look at those. So what ends up happening is you only need to look at the top element of the stack. Well, if you only need to look at the top element of the stack, then you don't need a stack at all. You can just look at the last element, the previous element, which is exactly what this makes use of. You don't even use a stack. You just look at the element that came before and look left to right. That's it. And that's it. And the element that came before is also the index that we're interested in. So we don't even need to. Well, we can use this kind of manipulation. This will work out fine. And then you just return -1, indicating that you didn't find an index. Neat. Right, obviously all these can be 0, 0, 0 greater than or equal to 0, all these indices. So what you're going to do then is, right, if you don't find anything, then you return no answer. But if you do find one of these characters, now what you're going to do is you're going to swap so to the right of this character, there is a smallest element that is still larger than that element. You want to pick that character. You're going to swap these two characters. So you found the character to the right of your character of interest that is both larger than the character. Let's call them A and B. So this character A is the one that we returned, the index that we returned. We're going to say to the right of the index of A, there's some character B, and B is larger than what's at index A, but B is the smallest such character that is larger than A. And then you're going to swap these two characters at those indices, and you're going to say, okay, take all the characters to the right of index A, and after you've swapped, and you're going to sort those characters. And then you're going to put all that together. And that's going to give you the answer to the problem, the smallest lexicographically larger word. Nice. That's what all this is over here. That's what I just described, but this is in Clojure code. Now, the tricky thing, and then you return the result. Now, the tricky thing, the thing we're struggling with here is the other day I got stuck at so my code was taking 800 seconds to execute, and we're trying to get the code to run in 8 seconds. And I got real frustrated. I was pretty I was suffering, right, trying to figure out what's wrong. As it turns out, what's wrong, or what was wrong, is it had nothing to do with my algorithm. And I was thinking that Clojure was just really slow, and I was kind of racking my brain trying to figure out what is wrong. Well, I did a little bit of profiling and realized that the culprit was not these. These lines of code didn't matter at all. Actually, the algorithm was sort of lightning fast with respect to what was actually taking a lot of time, which was I was continuously writing to a file at each step, which, if you're familiar at all with how memory works and page caching works and writing to disks and things of that nature, what you know is that writing a physical, for sort of crossing the software boundary to write to a hard drive, for instance, is very expensive comparatively. So actually, the problem, wasn't that my algorithm was slow. The problem was that the default approach to actually write the results would be writing to a file line by line, which is actually extremely expensive, especially if you're doing 100,000 writes, which is what we're doing in this algorithm. So that was the problem, is that we sort of needed to buffer everything and then write the buffer once. And instead of it now, I can show you how long it takes. We execute it after making that change. So before it took 800 seconds. Now it's taking it says about 2.6 seconds, 2.7 seconds, 2,700 milliseconds. And that's, I think this is not including the time it took for the, now if you counted though, it probably took a little more than that, maybe 8 seconds, because this is the time the algorithm started to execute, not actually the time to start up Clojure, which apparently it does take some time to actually, start up the Java virtual machine, which is kind of weird to me. But I was looking on some forums and found that that's the case, that Clojure has some startup time associated with it. So if we count, now let's try again. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it's a little over 8 seconds. Now, this is way better than 800 seconds, but as it turns out, it had almost nothing to do with Clojure. So I kind of, a few results from this, a few things we learned. One is my gripes, my discomfort with Clojure had nothing to do with Clojure. It had everything to do with I misplaced it. And actually, Clojure is really cool. It's really fast. It's actually very fast, and I'm like really happy to see that Clojure is actually pretty quick. That's one takeaway. Is Clojure is actually a lot nicer than I realized. I misplaced my frustration on the language rather than how this was implemented. Second thing is that this is a misimplementation, that if you're going to constantly write to a file, it's going to take a really long time. You got to buffer your inputs and then write, which is a pretty standard thing, kind of an obvious thing, but like something you can forget sort of easily. And that's something to remember. So that's the thing. It's like, okay, good thing we sort of went through this exercise. Another thing is you may not always want to trust HackerRank, because they do things like this. This was their code that came out, so I can kind of make myself, large in my ego a little bit more here, because it's like, well, trusting other programmers here. There's none good but God, right? That's what it says in the Bible. And then another thing is don't quit, right? Just because you'll learn something if you keep at it. Don't quit. You never know, really. Gotta have faith. Gotta have faith at this. It's not. It wasn't my. It wasn't that I was going crazy. Couldn't implement an algorithm correctly. It was just that we were by default running an extreme number of writes to the file, to the hard disk. And finally, I guess give credit where credit is due. Clojure's pretty cool. Sticking to it is good. And yeah, I guess finally, I think I may be able to increase the speed a little further by using a batch write, a read as well, instead of reading a line by line from a file. Maybe I should also read the whole file in. I'm curious if that'll speed us up for the last few seconds. Yeah, we're actually not even done with this problem yet. There's still a few more seconds that we need, even though we were able to reduce this from 800 seconds to 3 seconds. We're still a little behind. Also, we learned that Clojure has some startup time. Hey, what's the best way to learn a programming language? Just write projects or actually do HackerRank stuff. Hello, Ash. Forgive me if I say your name incorrectly. Asihe. I'm trying. I'm gonna call you Ashe. I hope you don't mind. I hope that's okay. Best way to learn a programming language. The only way to learn a programming language is to use it. So whatever that means to you, whatever you want to do. The thing about programming languages, though, that's kind of important to know is that they're tools, and they're usually built in a I would call it a quote unquote thematic way. There's like a sort of a general theme. So like each language is usually kind of colored by like what you would use that language for. Like as an example, JavaScript is pretty much consumed exclusively by browsers. So that's what you write your websites in JavaScript. So it has a kind of form follows function kind of thing about it. Like it's a lot slower than some other languages, but it's a lot faster to actually write the code. And it has like huge numbers of libraries because like browsers everywhere use it, so it's got a ton of stuff in it for doing all kinds of cool things. But it carries with it all kinds of sort of idiosyncrasies. And then another good example to juxtapose that, like the actual browser itself is written in C++, usually, just about all of them are C++. And the reason for that is C++ is extremely fast. But C++ is built for like backends and like applications and like real seriously, like where performance is extremely relevant. And usually that's like very big applications are built in C++. Things that have like millions of lines of code usually be C++. And C++ is verbose. It's strongly typed. That's one of the reasons why it can be compiled so quickly. It also has what's called idiomatic C++, which is there's all kinds of intricacies that come with the C++ paradigms, which are basically problems that people ran into while programming C++, like big problems, and problems that are kind of hard to catch, subtle problems. And so you might be accused of not being a good or decent C++ developer because you don't know idiomatic C++, which is ridiculous. While it may be somewhat true, it's the only, to remedy that, all you need to do is pick up a book on C++ idioms, and there you go. Now you're a, much better C++ programmer. So yeah, so what that implies, the reason why I'm babbling on about all of that is, basically, whatever language you want to learn, you probably want to pick a use case that fits that language. So like for me right now, I want to build a website. I wanted to learn functional programming, Clojure being one of them, but I want to build a full-fledged website. And the thing that I'm really focusing on is I want to build it in a way that is immutable. In other words, there's a certain error that a certain class of programming problems that I ran into while I was working on another website, and I was like, hey, I want to see what a website would look like if I did all of this in strictly Clojure and Clojure script, which Clojure script is actually Clojure that compiles to JavaScript. So you can build the front end actually it is JavaScript, but it is the Clojure sort of syntax, the Clojure language being applied to that. So like that's the problem I'm going to work on. It's like kind of specific. Like I'm going to build the front part of a website in Clojure script, and I'm going to build the back end in Clojure. I'm probably going to switch the back end from Clojure to OCaml, by the way, but it's similar. It's still functional programming, but the overarching theme is I wanted to learn functional programming, which Clojure was built for functional programming. Almost explicitly, and there's another piece in there is that I have an interest in machine learning, and concurrency is extremely important with machine learning. Doing sort of, if you really want to do things quickly, it's kind of more like GPU programming, but there's a lot of concurrency stuff involved, and functional programming languages are extremely good for concurrency. So there's sort of a whole bunch of stuff wrapped up together that I'm kind of doing this. Like it's not just like I wanted to learn Clojure. It's like I want to learn Clojure for a set of different reasons, and then how I'm going to go about learning it. It's like a whole bunch of different pieces to it. Yeah, I would suggest that. Like, the more languages you learn, the more programming you do, the more this kind of stuff will sort of materialize. Like as you're learning, like what would be a more effective way to learn. But I would just say like, you kind of want to pick a direction because it's a tool that you're learning how to use a tool. So you actually got to like, it's like you wouldn't learn to, I don't know, use a hammer by like trying to screw screws. You kind of want to find like, okay, if I want to learn how to use a hammer, let me go find something that needs a bunch of nails. That's kind of that's sort of the best way I think to learn a programming language. That's what I'd suggest. Now the reason I'm doing the HackerRank stuff is, I like programming. It's good for interviews. I mean, I like algorithm questions. It's good for interviewing, but it's also very good for like syntactical shenanigans. In other words, like just knowing like what's the read line syntax for reading another character from or reading another line from an input. How do I get the time at any given point in Clojure? How do I get environment variables in Clojure? How do I get, I don't know, how do I just update a value in a collection in Clojure? Like all those little details that basically is syntax. HackerRank questions are really good for just practicing the syntax, just so you get like a little bit of muscle memory. Yeah. I would say to learn the idioms, you kind of got to go to textbooks for a particular language. If you want to just learn the syntax, just going through problems and constantly going back and forth through the documents, HackerRank is pretty good. But if you really want to learn like the full-fledged, the full package, I'd say a small project is good. So a small project that's kind of geared, you know, like so if you wanted to do like learn JavaScript, you'd probably just build like a small front end thing that's in JavaScript, something simple, but complex enough where you get like some, you know, maybe you want to learn like React, then you might build some front end that like, you know, you click on some buttons and it does something. I don't know what you could build, but you know, you could think of something. I mean, it doesn't have to be that complicated. I mean, it could just be, could be as simple as like a very simple game, you know, like I don't know, just actually I really don't know. React is a little more interesting because it's more for like building GUIs, I think, or it tends to be used for that. You could technically build a game using React, but um, I did. I mean, I did. I didn't really use React. Kind of, yeah, sort of. I could show you that if you're interested. But that was kind of overboard, though. That wasn't a small project. That was like way more work than it was worth, kind of thing. I actually was thinking I should revive that project, just because I could like make a few bucks. Although I'm like not ready for that. Like I got other things I want to do before I do that. But it was kind of neat. The project, it was kind of neat. It was a lot of work. Anyway, I'm kind of rambling on now. Let me get back to what we were doing. So, yep, just practice. You know, the only way is to just keep you know, just keep working with it. Do something with it. So the problem I ran into now the question is okay. So the problem I ran into here is I solved this problem and I made it a lot faster, right? But the issue is it's still not fast enough. It's not quite fast enough. And if we execute, it won't pass the same test cases. It still takes a little bit too long. And I think we can verify that locally, right? So if we count again, 1, 2, 3, 4, 5. Excuse me. Sorry. We'll do that again. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so it's like 9 seconds. We're supposed to do it in about 8 seconds. This says 3 seconds, but I guess it took, for whatever reason, it took 6 seconds just to get the program to start up, which is really weird. I don't really know why that would be the case. So what I want to try to do is let's just read all of let's read all of the lines in one shot. See if we can do that. I wonder if that matters. Let's see if we can read the whole thing. Okay, yeah. And the buffer only has 4 8K. Well, actually, oh, no, never mind. Okay, let's reading line by line. Let's try to read all the lines. Read all lines. I could actually use Java's interop to use some Java functions to read all the lines in one shot, if that's necessary. What does this do? Returns the lines of text from reader as a lazy sequence of strings. Reader must implement buffer reader. Line sequence. So what we can do, we can say, let's do this. Let's do this, and let's do this. Yes, we can put one here. We can put one here, so this is the beginning of reading line by line. And then we can also say We can also say count line sequence reader, count line sequence in. Okay. Does this work? I want to see, I want to know how long, I want to see, let's see what we get here, see if this compiles. Let's see if this compiles. No. Why though? No pointer exception. Which one? Invoke static, trim, invoke, compile eval, load eval, invoke static, invoke, do invoke static, invoke, no pointer exception, main, apply to var, invoke, what is it calling though? 107 says? No, that's not right. Init option initialize, null option, function apply to rest. I don't know, what did I do? It must be this, right? I mean, it must be this line. But why would that be? Yeah, it is that line. I mean, it must be that line, but the question is why? Oh, I think I know. Empty string is null. Standard input. Do I need to do this? Maybe that's why. Could try that. Use the interop. Let's see what happens here. No. Yeah, I think the issue is that it reads everything in here and then it's null afterwards. So I'm fairly certain the input is already a buffered reader. I think I know what the problem is. I think the reason for the exception is because we've already read everything out of it, something like that. I think that's why. But yeah, it takes 100 milliseconds about to go from here to here, and then if we don't read, if we read piece by piece, it looks like it takes 200 milliseconds. It takes twice as long. Well, I mean, it's a way to shave off 100 milliseconds, but I don't think that's enough for what we're trying to do here. Shucks. Yeah, it's like a full second that we're behind here. We could try this, see what happens, see if it goes any faster. All right, the way we want to do this is. Yeah, watch this. This is. We want. Input. It's going to be a line sequence of in. Oh no. Can I do another binding here though? Maybe I need another let. I'm not really sure, actually. Thinking about it now. Shucks. Uh-oh. Uh-oh. Let me see here. The problem is I've got to actually feed this line sequence in somewhere. Well, you know what I can do? Just, I think I have an idea. I'm going to do one of these. This is going to be interesting. Alright. It looks like we're reading... I think I'm going to have to execute on this anyway, or have to split on the new line character. Shucks. It's going to cost 100 milliseconds anyway. Doesn't really save us much, does it? I guess not. How do we do this? How do I do this? I think, alright, let's try split. Let's try split. Let's use a regular expression. Okay. Alright. And the regular expression comes second. This regular expression is going to be the new line character. So I think you can use a single character in a regex, I hope. Maybe it's just got to be like this. Hopefully that works. May need one of these. I don't know. Let's see what happens here. Oh, actually, we can just run it and not guess. Oh no. Shouldn't this work though? This is just a bunch of characters. I'm a little confused. I don't know what data structure this is. If it's like a list of characters or something. This sequence of lines. I'm curious what this will do. Got questions, man. I got questions. But yeah, this is the kind of stuff that like messing around with HackerRank helps you sort of learn. Like, you can do all this a lot faster. You don't have to like ask all these questions. Like the thing I'm wondering is like, does this return a string that I can actually split on? I don't think it does. I don't think so. Maybe the problem is Clojure no, is that the problem? Maybe it just doesn't know this function. Invalid token. Yeah, before it was, oh no, it's still invalid token. Yeah, okay. How do we make a regex here? You could do something like this, but it's not the best. I don't think this matters either. unable to resolve symbol. Yeah, so it does need Clojure, not string split. Okay. Yeah, this like 4 or 5 second startup between each run is kind of bad, I think. If we loaded this directly into the REPL, this would be a lot easier, I guess, I think. 6. Alright, and then we gotta run this, and this string copycast to regex pattern. How do we specify regex patterns in? Oh, that's why. That's what I'm missing. Got it. That's my mistake. Supposed to use a, I completely forgot. That's how you specify regex patterns in Clojure. It uses a special character for the compiler. Wait, what? Cons? What is going on? Character sequence. Can we make this a string? Wow. Alright, what if we do this? Is that the problem? We gotta convert it to a giant string first? Is that the issue? Oh, look at that. Wow. Oh, we're gonna be here for a while, huh? Quite possibly. It's a lot of characters to print. Yeah, alright. Now, this string got split to a whole bunch of new line characters. And I guess it's a collection now. So I don't know what this is all about with these spaces. It's printing it, but I don't know. What I want to do is define result to be, we're going to map this guy. We're going to go ahead and map this guy to each of these after we split the thing, and then we're going to, we actually want to do 2 things with this map. We want to say first, bigger is greater, convert this value, and then we want to I don't know, man. Sheesh. So we get our input, convert to strings, split on the new line characters, then we're going to map that collection one by one into first is bigger is greater, and then we're going to also conj a partial conj another function here, which is or just function, which is conj of x and the new line character. It's actually the string. These are strings we're manipulating now. Add back the new line character to each of these. And then finally, do it piece by piece here. Finally, at the end of all this is I actually gotta join everything. Yeah. Nice. Oh boy. This is good. This is good. Holy guacamole. And we're not even gonna print it. We're just gonna write it. Just write the thing. Jeez, man. What happens if we do this? It's gotta give me some error. There's no way this works. There's no way that this works. No, as I thought. Valid token new line. This is the character. Is it forward slash or backslash, you know? It's backslash. That's the mistake I was making. This may be very well just be a single backslash, both cases. Wow. Function did not conform to spec. I don't know what went wrong here. What do you mean it didn't conform to spec? What do you mean it didn't conform to spec? What? What are functions? What do they normally look like? Oh, I couldn't thread it, I think is the problem. Name, params, expressions. Don't give me that, it doesn't conform to spec. Do you even know what you're talking about? Do you even know what you're talking about? I think the spec it's not conforming to is this threading macro. I think that's the issue. That's annoying. It's okay though. It's fine. There we go. So a bigger is greater to get this new string, and then we concatenate that string to the new line character. That's our anonymous function. And we map that to each of these. And then we join everything and spit it back. And we have to save this first. Alright, let's see how we do here. It's a lot more work than I thought it was going to be, just to make sure we're sort of reading in one shot the input, because we're not really, because this would automatically split, sort of automatically split on the new line characters. No, we're not doing that automatically. We gotta code that in. We're running into some issues. Okay, so we do need a regex of this type. Now that is confounding. We can do. Yeah. What if we do this? Hopefully this is read properly. See what happens here. See what happens here. Tisk, tisk, tisk. Oh, okay, nice. Function pointer depends true. I agree. I agree. Let's see how this goes. Amazing. So the rest of it seem to have worked correctly, I guess. I don't know what happened. We'll see. See what happens here. That took a lot longer. That took 4 seconds. That's terrible. That's quite a bit worse. That's losing 2 seconds, not gaining time. Shucks, man. I think the problem is because we're reinterpreting these things as strings rather than, oh, it's not even, oh no, it's not even correct. Jeez. Uh-oh. That's not good. Oh, I remember, right, because this is, okay. Should be, yeah, because this does return a vector of things. You know what we can do? We can maybe optimize this a little bit by assuming this is a vector of things in the first place, and we can actually create a vector of things. Now, what kind of object is this, though? This line sequence. I wonder. All right, does this work? Let's just check this first. So itchy. All right, 4 seconds. Now what I want to do. I get this feeling that's going to happen a bunch in the future. I have this feeling if we get rid of this guy, this might still work. Let's see what happens. Let's find out. I don't think so. But we'll see. No. Yeah, because this is supposed to operate on a string, not on a sequence. Or on a, this cons. How do we do this? Definitely don't want to just convert this all to one giant string. Excuse me, that would be a bad idea. We do want to split this though on every new line character. Interesting. How can we do this? Clojure cons, I wonder. X is the first element and sequence is the rest. So this is a sequence that we're looking at. That's what this is, a sequence of characters, really. We can get the next sequence, I guess. We could process sequence by sequence. But that seems kind of bad. Also, by the way, we're supposed to get somewhere here the first integer from this sequence of characters, which is going to be the first new line character. Yeah, I kind of like just reading lines, reading line by line. Seems good. That actually seems really good right about now. Because you can read the first line. Well, you know what you can do? You can read the first line and then read everything. You know what I wonder? I wonder. Let's comment this out. Look at this cheeky thing to comment things out. If we take this line sequence, since it's a cons, what does this do? Oh, it does. I was wondering if that's the case. It looks like this reads in line by line anyway. Oh. Oh, I see. So in that case, I don't need to split anything. Very cool. So we can go back to what we were doing here. We can say, don't need to conjugate anything. We could do bigger is greater. We're going to map. So this is just the sequence. And we say bigger is greater. And then kind of want to perform a reduction on this. Or into, we can even just into. Or, well, that's a good question. How do I want to do this? Well, the collection we get after a map is what? What do we get after map? This is a sequence, right? lazy sequence. Yeah. Get a lazy sequence. Okay. We don't need this conjugation anymore, certainly not. Although, actually maybe that's fine. No, that's fine. It's a sequence, right? So could do one more function here, and that's Clojure join. That's what I did down here. Yeah, this result, what's going to happen is you process the input, you add a new line character, and then it's a vector. This vector then becomes a string, and then this is a sequence of strings, and then you join this sequence of strings and then split it. Could try this, see how it goes. Done. Nice. Now the question is this any faster? I don't think so. I don't think this is much faster, man. I think this is like exactly the same algorithm. This is not much faster, actually, as it turns out. Okay. Yikes. Yikes, 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 yikes. What I'm thinking is, maybe we can process this in a way that's faster, this part. Instead of converting this to a vector. Maybe convert this to a vector once, and then manipulate the vector. No, I don't think so. Excuse me. Maybe I can use sequences for these things instead of vectors. Temporarily. Excuse me. Is there some way to perform these calculations faster? It just needs to be a little bit faster. let's try this. Let's try just like removing, like if I remove all these lines, how much do I actually gain in terms of speed? Just pretend for, oh, that's not what I meant to do. And let's just have ret is w. Right, so you just return, perform this execution and then return. See how fast we are now. What? This was working before, right? Let's make sure I'm not going crazy here. Okay. Yeah, a little over 2 seconds. Alright, so for reasons that are beyond me, I don't know, we can just set ret to like W. I guess it's because there's a whole bunch of operations that occur on W. 9:30. So yeah, this does cost time. This is expensive. And we even go so far as to see how much time we save for this single line of execution. Oh, made a mistake. We could say I did this wrong. Wow. So this is very expensive. This bit. Okay. So that gives us opportunity for reasonable. It's about three times slower, 3 times the speed, or at least 700 milliseconds, whatever it is. So that's a lot. It's pretty considerable. Put this back. Try again. Take a look at this. How fast it is. How slow it is now. It's like 700 seconds, 900 seconds rather, 900 milliseconds rather. Yeah, it's a big difference. It's a few hundred milliseconds. So I wonder if there's a way we can perform this algorithm that's more efficient. Well, this only happens once. These are not too bad, I think. But we are filtering, so we are ranging over strings. We could convert this string to a vector first. Let's try that. As vector. W. Then we can say nth. Let's see if that makes things any faster. I get this feeling it doesn't, but we can find out. Also, I'm falling asleep here. I'm so tired. A little faster. Not much though. It could just be like variance, random variance. No, it's 40 seconds twice. 40 milliseconds rather, that's considerable. Okay, another 60 milliseconds for no particularly obvious reason. Let's see. Oh wow. Okay. Holy guacamole. That took an extra 300 milliseconds for no obvious reason. Yeah, that's that's a little strange. Okay. It's like, come on, man. Come on, man. I don't think that really matters that much. um, um, oh, I have an idea. Aha. Ah, maybe this is a little bit better. I need to apply int over and over again. This is, I think, slightly better. Let's try again. See how this goes. Wow. That makes it a lot slower, huh? Jeez. Oh my goodness. You're kidding. Okay. Oh, no. You don't want that. No, no, no. So I wonder if I could just compare these directly, these two. The characters, one next to another. Oh, come on, man. Come on, man. Character cannot be cast a number. Really? You don't do character comparisons in Clojure? Just trying to get a little bit Juicy and delicious. That juicy and delicious. Speed boost. We all know and love. When your juicy and delicious speed boost that we all know and love when you're looking to remove some functions from your nested functions. Never looking for identical, looking for the comparison. 0. Shucks. Excuse me. Three-way comparators. If I just want to compare characters. Okay. Shucks, man. Shucks. What am I doing here? I'm thinking. Also thinking maybe I should go to bed. I wonder if I should use reduce rather than apply. Also, if that speeds things up at all. Can't use a less than, huh? Alright. Oh, man. So as far as the comparator is concerned, I think we need to use compare, which I really don't want to do. I don't want to do that. Trying to reduce the number of functions that we call here. Yeah, because the problem here is like, if you take this comparator this way, the issue you run into is, one, it's probably slower, and two, it's not going to have the same kind of correctness. As I bet you in Clojure, -1 goes to true. I could test this myself, I think. If we just print, wait, what? Bool in this context? True. Is this true? Tell me. False. Oh, cool. -1 is false. Awesome. Nice. I can use what I want to use. Hey, can go ahead and save. $8.94. That's still really slow. Still very slow. Can we at least do that? No. Well, let's see. That doesn't really speed anything up at all. Doesn't do anything for anybody. It was 900 before, it's still 900. Okay. Whatever, I guess. You gotta be kidding me. I think I should just go to bed. Alright. If there's a way to speed this up, I'm not seeing it. That's 700 milliseconds right there. Over 100,000, cases. Maybe this has got more. Well, yeah, there's another, like this is like a full second, 2 seconds almost of work that's being done. So I guess if we, Hmm. Hmm. Oh, excuse me. So I'm wondering if I can maybe shave off a little bit of time by processing both the, so this set is kind of a series of operations here where it's the numbers that are the smallest number that is larger than the number located at the which index. And what we want to do with that number is get its index of any such number. So, and then we want to swap and perform a sort. Huh. Excuse me. Can we get the minimum element and its index at the same time? Now remember, it's not the minimum. Oh yeah, we can do this. This is fine. I know what to do. I figured it out. We can just use a reduction. I know what to do. So we'll get this right min character. No, right min indices, which is it's going to be yeah, I know what to do. Let's say right larger, just say right indices, right? So what we're going to do is say, I know what to do. Ich habe eine Idee. Where's, yeah. So what we're going to do is not apply, none of that, no. We're going to actually create the whole thing from scratch. So count of, take this right side, right? And we'll say count of right. And we're going to go ahead and say apply a filter. Which is almost exactly this. So now these aren't the integer, this is, it's going to be right of this value, not as an integer. Well, we'll compare. And we'll say substrings vector. So we get this character, and then we have this which character, which doesn't need to be an integer, by the way. So we compare these two, and we say we want indices of things that are larger than this which character. And then we're going to reduce on to a certain index with this custom anonymous function, or what's filtered. Now these are indices, it's filtered. So what you're going to want to do is say, given these two values, which is the current value and the new value, right, 0 and 2, you're going to compare actually no, these are just indices. You want the smallest index. No. It doesn't matter which index you take. You want the smallest of these values. Ah, yes, that's the part that's interesting. Okay, so you're actually gonna do a minimum of the current value, and it's not the current value. It's going to be right of the current value against right of the next value, and you're going to start with right of 0. Not right of 0. Interesting. Yeah. Let's do it this way. Let's apply the filter first. And then we can say, and min right, or just right character. And then we can reduce on this right indices. This is actually just going to be the first of these right indices to start with. I think we're going to want, does reduce have an initial value? I think so. Function value collection. Okay, let's try this now. So indices becomes an index. That's what we want. So we don't need to call this index of. And alright. So what happens if we do this? nice. Which one are we calling here? You're calling, but I can't hear you. I'm not listening anymore. You're subject to falling, but I can't hear you. You know, I think I'm trying to keep my voice down because my dad's sleeping. And yeah, I don't want to talk too loud. It's like he's like right above me. Invoke. Filter, invoke. iSequence from Java lang integer. Which one is causing the issue there? Oh, I see the problem. I see the issue. I see the issue. It's yeah, can't create a sequence out of just a single integer, which is just the count. It was just the count. Oh, I see. Well, you just want to return the one that's larger or smaller. Compare's not really the one you want. You could throw an if in there to make things a little more interesting. Well, I'd really rather not. I mean, I can, yeah. Okay. I mean, yeah, I could throw an if in here and just make it. I don't think any of that's really useful for what I'm trying to do. I think what I want to do is just write my own if statement here. So if it's true, that means we return it's 1 or 2. I don't recall which one comes first. That's not too bad. Yeah, I think I want the minimum. So if 1 is less than 2, too many arguments to if. Oh, okay. True. Correct. Indeed. I'm falling asleep over here, man. Too few arguments to if. What? Wait a minute, what? If, then else, right? Excuse me? Too few arguments. That's not true. What? What is going on, man? This should be enough. This statement just has 3 pieces to it, right? 1, 2, 3, yeah. Oh, why do I have? Okay. I don't know. I got confused. Got confused. Oh, sweet. Shaved off a bunch of seconds. Cool. Now, is this correct, is the question. You're falling, but I can't hear you. I'm not listening anymore. You're calling, but I can't hear you. You're falling. Oh, it's wrong. Nice. Great. Great success. You're calling, but I can't hear you. I'm not listening anymore. What did I get wrong here? You're calling, but I can't hear you. I'm not listening anymore. You're falling. Maybe it's gotta be 2-1. That could be wrong. Maybe that's the issue. It's probably that. It's probably the problem. You're calling, but I can't hear you. Why? What? My output, BB. Huh? Is that why? It's just because of the... Oh, this is wrong too, though. These are all wrong. Not all wrong, but wrong. These are wrong. What's going on, man? Isn't this... So this part seems to be the incorrect part. Why though? It would seem that this comparator doesn't work the way that I would like it to. I think that's the problem. Excuse me. I was hoping to just compare directly character to character, but I don't think I can. If you do something like this, if you do something like compare, and you've got, you know, A to Z, or Z to A, right? This is going to look strange. False, false. Do you see the problem? Okay, they both be false. I think that's the issue, is that this compare doesn't really give you true false. Now you can say, now you can do if, and you can say yes, no, and see what happens there. And that's a worthwhile question to ask. What is the, because that's really what I want to know. So what is the truthiness of this thing here? Finally, you've got, if they're equal, what do you get? What happens here if we do this? What happens if we do this? Yes, yes, yes. Come on, man. Come on, man. Are you serious? What? Oh, no. That's terrible. What do you mean? This is just always true? Is that a joke? Is that a joke? If you just put 0 in here. Excuse me. What? Okay, I don't think we can use this comparator here. I think if we want to use this comparator, we gotta use a one of these guys. So, I think, what is it? I don't use the REPL very much. Maybe I should start using it more. Maybe I should start using it more. -25 it says. Alright, so if A is less than, so if it's less than 0, that's a true, right? That's a smaller than. I can use that. Get some results here. I was trying to avoid doing all these extra. Looks like I can't avoid it. Trying to avoid these extra operations. No, that's fine. It's necessary. It's necessary. What are you gonna do? Yes, no, no. Okay. Got it. Got it. Point taken. Point taken. Yeah, that's great. You're falling, but I can hear you. All right. Oh, really? Well, that sucks. Key must be an integer. What? Where? What? Is this no longer an integer? These are integers, no? Oh no. Oh no. I'm so confused. Which line is this being called on here? Oh no, man. Come on, man. Excuse me. What's this line? It's causing issues. It is. Nice. Why though? Why is this line causing issues? Alright, try again. We go again. I thought as such. These are empty. Right. I see. You're falling, but I can't hear you. I'm not listening anymore. You're calling. So nothing is passing the filter. That's the problem. Yeah. And why? If you compare, so what we want is, if this is smaller than this character, then we don't want that. So we only want things that are greater than, right? Nice. Alternatively, we can do this. Yeah, I kind of like keeping things somewhat consistent though. Left to right. That should be fine. Never mind, I'm not keeping anything consistent with that. Never mind. I think it's okay. Let's just leave it as it is. It's not super obvious what's going on here, but it works, or at least I think it works. Yeah, so we saved some time doing this. 17, saved about 500, almost a full second. Shaved almost a full second off by rewriting this a bit. Now let's try again. See if we can get this right now. Let's see what we do here. Nice, that's correct. Okay. And if we run our code, what we want to do is also throw in this bit. Read line into the reader. Still timed out though. You gotta be kidding me. You're calling, but I can't hear you. I'm not listening anymore. You're falling, but I can't hear you. Alright, now it's definitely time for bed. Now it is definitely time for bed. Get rid of all this, I think. Alright. Let's see about this now. Come on, man. What did we do wrong? Oh. Okay. Uh, hmm. Hmm. Interesting. Could do something like this. Bind into reader of in. Call the rest of this. How about that? Does that work properly? Ah, it does. Okay, nice. So I'm curious how long this will take. looks like it's passing, but I don't think it's passing. We did it! Yes! Ah! Ah! Just in time for bed, too. Amazing. Amazing. Dude, that is wild. Holy guacamole. That only took like 5 days, 6 days. It took forever. So we needed a combination of things. And probably a little bit of luck too. We probably like just made it on these test cases. You gotta be kidding me. Dude, that's crazy. That is crazy. Alright, we did it. Yeah, so we learned a bunch of things doing this. We learned a little about the compare operator and reduction, filtering, some induction here, messing around with vectors and substrings and filters and indices and using conjugation and association and spit and join and map and line sequence and this IO reader, job IO reader, using environments, like all kinds of goodies here. All kinds of goodies. Heck yeah, man. Wow. Okay. Buffering, right? Writing to efficiently writing from a buffer instead of, you know, performing 100,000 writes to a file. We can just buffer our output and then write it once to the file. All this stuff. Holy smokes. Alright. So yeah. Thank you for watching. I'll talk to you all soon. Have a good rest of your night. And yeah, man, we're gonna go to the next challenge. We should probably do, I'd say maybe like eight more problems in Clojure. Hopefully they don't take a week for each of them. Yeah, we'll do that. We'll knock out 10 total. So we got 2. We'll try to go for 10. And yeah, again, thanks for watching. Have a good rest of your night. Talk to you soon. Goodbye.